Welcome to the logic part of Math 1. Maybe you already saw that Math 1 consists of two parts, set theory and logic. You can learn them independently or you can mix them up, whatever you like. So this is the first lesson of the logic part. Let's begin with the most basic issue in logic. We start with a proposition. And a proposition is something where you can say this is true or this is false. It's, by the way, not relevant whether you know the answer to something, but it's only essential that someone can say indeed that it's true or it's false. For instance, if we look at the proposition 5 minus 4 equals 1, okay, someone can say, and hopefully that's you, can say this is true. So a proposition is something for which we know that there is an answer. It's yes or no. So for instance, 3 plus 7 smaller 2. Okay, that's false. So we know the answer. But something like this, x larger 5. Okay, then we get a complete blank because we don't know the value for x. So the first two are propositions because they are sentences for which we know they're either true or false. And the third one is not a proposition because it depends on the value of x. If we have a proposition, then we can also combine them, and then with an expensive word, it's called a compound proposition. So propositions we combine. For instance, the proposition 5 minus 4 equals 1, and a conjunction, and 4 plus 2 is smaller 7. Okay, and then we need to be able to give an answer of this complex, this combined proposition. And then, in fact, you can use common sense. And so this one is true. The next one is also true. So if we have the combined statement, then that will be indeed true as well. To have a mathematical way of doing it, we need to look at a truth table of a compound proposition, and then we start with two simple propositions. We call them P and Q. They need to have a name, just any name. And then we look at all possible combinations of the values. So for instance, proposition P could be true and Q could be true, and then we'll normally write this with a 1. Or P could be true and Q could be false. That's a nice combination. Or P could be false and Q could be true, or both can be false. And so then we have all possible combinations. And then the compound proposition P and Q is defined as follows. If both are true, which we saw in the example, then the compound proposition is true as well. If one of the two is false, so if the first one is true and the second one is false, or the first one false and the second one true, then the compound proposition is defined as false. And of course, if both are false, then the compound proposition is also false. So this is the truth table for AND. We can also look at an OR, a disjunction, so P or Q, and P or Q is true when one of the two is true. So this situation it's true, P is true, Q is true, and only in the situation when both are false, the disjunction, the OR, gives us a false. And there is one last one that's called the negation, but the negation only applies to one proposition, so it is not P. So we have P with two possible values, and then the negation is not P, is defined with, if P is true, not P is false, and if P is false, not P is true. We can also combine statements with an and a not and an or, whatever we like, and then look at the outcome. So for instance, we have a statement not between brackets P and not Q. Okay, how can we know what the outcome is of this one? We can just use a truth table. So we have two elements, P and Q, and these 4 possible combinations. Okay, then what we will do is we just start with the smallest element first, and the smallest element in this case is not Q. So not Q will give us 0, 1, 0, 1, if you compare it with the second column. Okay, then we extend it a little bit, we expand a little bit. So now we expand it with P and not Q. So we need to look at this column together with that column and use the definition of an AND. So we have 1, 0, so that gives us 0. We have 1, 1, gives us 1. 0, 0 will give us 0. And 0, 1 will give us 0. Okay, then we have one thing left, and that's the not in front of the complete package. So not P and not Q. So then we'll just look at the last column, and wherever there's a 0 we put a 1, when there's a 1 we put a 0, etc. So the total answer is this column. So now we know when this complete compound statement with a combination of a negation and a conjunction gives us true or false. And you see we've worked with brackets, but it's also nice to know the priority rules. So if we look at the priority rules, then we should know that not has the highest priority. The second one is the and the third one is the or. And then we will agree that the not we will use without brackets, but the other two we will use with brackets. So most important is that you understand and remember that not has the highest priority, but on the exam, if we have an and an or, we will always use bracket to make clear what has the highest priority. Okay, then we can also have special truth tables, and there is one which is called a tautology, when the result of the combined statements results in one all the time. A contradiction is the opposite. So then we say, if we look at this compound proposition, then the answer will always be false. That's a contradiction. And then of course the last one, equivalence, if two propositions are identical. Let's have a look at an example. And the question is, are the following sentences equivalent? Well, then we have a complication because the sentences are in English, and of course we don't like that. We'd like to talk with P's and Q's and abstractions. So let's just try to define our own abstractions. So I see one here which says John speaks French. So let's call that one P. So P is John speaks French. And then I see another one, John speaks English. So okay, let's call that one Q. John speaks English. And then the first sentence we can translate with the sentence with the compound statement. It is not true that John speaks French or John speaks English. So it is not true, negation, that John speaks French, P, or John speaks English. Okay, and apparently we need to investigate whether that is equivalent with John cannot speak French, so not P, John cannot speak French, and John cannot speak English, so not Q. Okay, well, let's try to figure that out. So to see if something is equivalent, we need to make a truth table. So we have P and Q with 4 possible combinations. Okay, let's do the left one first. So then we start with P or Q, which is 1, 1, 1, 0. And then the next one would be not P or Q. So that would be 0, 0, 0, 1. Okay, that's the left part. Then we'll do the right part. So we start with not P, which is 0, 0, 1, 1. Then we have not Q, which is 0, 1, 0, 1. And then we combine them, not P and not Q. So that would be 0, 0, 0, 1. Okay, that's nice. And then we see that the column for the left part and the column for the right part are identical. And that is the definition of an equivalence. So, in fact, it is not true that John speaks French or English is equivalent with John cannot speak French and he cannot speak English. Okay, let's have a look at another example. So, it is not true that John speaks French or English, and it's not true that John speaks French and English. Okay, we had John speaks French with a P, huh? So it's not true that John speaks French, P, or John speaks English, not P or Q. And the next sentence is, it is not true that John speaks French and English. So, okay, are these equivalent? Well, let's give it a try. So we need to investigate whether not P or Q is equivalent with not P and Q. Okay, let's make a truth table. So PQ 1, 1, 0, 0, Q 1, 0, 1, 0. Okay, let's start on the left again. So first P or Q gives us 1, 1, 1, 0. Then we negate that one. So not P or Q, so that will give us 0, 0, 0, 1. Okay, that's it. So let's do the right part. So we start with P and Q, which gives us 1, 0, 0, 0. And then we negate that one, not P and Q. So that would be 0, 1, 1, 1. Now, if we compare those two columns, then they're definitely not the same. So they're not equivalent. Let's have another exercise. So they want us to make a truth table of this complicated compound statement. Well, let's just strip it to the basic. So let's start with not P. So that would give us 0, 0, 1, 1. And then not Q. So that would give us 0, 1, 0, 1. And let's combine. So not P and not Q. That would give us 0, 0, 0, 1. Okay, so then this part is done. Then let's first do this right part, P or Q. So 1, 1, 1, 0. And then we have to combine the left and right one with an and then just because I'm lazy, I will give these numbers. So the final result would be 1 and 2. So column 1 and column 2. That would give us 0, 0, 0, 0. Okay, so if we remember correctly, then this is a contradiction. So there is no combination of values for which this complete compound statement can ever be true. Okay, that brings us to the end of the first lesson. If you have any questions, feel free to contact me through Teams or through mail. Hope you enjoyed this logic part, and we'll meet again for the next video.